let me just reiterate. We basically have this data set of Amazon books, and you can get it on our Discord. I put it like in the resources area, and also the iPi notebook that we're working with, and like the essential questions we're trying to answer, basically. And today I'm just going to go over how we're going to read in the data and then basically answer these questions. Okay. And then, yeah, so we have all these books, and then these are like the name of the books, the author, and then like the ratings and stuff. And then, yeah. So first, this is like just a generic CSV file. And we want to first like import the necessary libraries to be able to basically get it or to read the CSV file into our Python program, right? So it's easier if you guys like follow along, but I'm just gonna start by importing pandas, and pandas is gonna be our library that we're gonna basically be using most of the time to scrape data from CSV files or like JSON files. So if you guys, I don't think I introduced libraries just yet. So think about it like this, like this is like our program, like our program is like in the center of everything. And then basically there's other libraries that we can use on from like the outside, like pandas. And then we can use basically their functions. And we're going to be using pandas, and we're going to be using matplotlib because we're going to be like plotting stuff basically. Yeah. And I know this like file looks different, but this is just like a notebook file. And yeah. But you can basically have, this is like our home program. And then we basically import in other libraries because people have like pre-coded functions and stuff. And then we want to use their pre-coded functions. And that's why we have to import their stuff, because we don't want to have to like code everything, you know? And because everyone already like coded like stuff to make it easier for us to read in the data. And I'm gonna annotate it. So this is like to read in data, and this one is basically the plot stuff. Okay. So if you run that, then we would have imported everything. If you don't have something installed, you can basically do something called, you can do like exclamation mark pip install, and then that like library. So let's say you need to install matplotlib, then yeah, you just put the exclamation point and then that, or like pandas or something. And the reason why we import it as PD at the end is because it basically allows us to have like an abbreviation. So we don't have to type out the whole thing like pandas every single time. We want to use a function and stuff. So I basically said like the libraries and stuff, and I talked about the functions. So I want to show you guys like an example, like what am I even talking about when I'm talking about functions? Like, well, what functions are we using, right? So here, the CSV file is in like the same spot. So let's say we want to read this CSV file into our notebook, right? So we define a variable. It's called, I'm gonna just call it df, and I'll explain that later. But we can do something called pd.read in this CSV file, and then we basically put in like this name, which now I think about it, it's like a pretty bad name because there's like spaces and stuff. But yeah, we can basically read it in, and then let's just that. So the reason why we call it df is a like a abbreviation for data frame, and data frame just basically stands for like the type of object that we're dealing with. Okay, so you know how we had like integer, we had like double floats and then strings, and then like there's lists and all that stuff. This is just like another type of data structure we're working with, and it's basically putting all this CSV file stuff into our program basically, and it makes it easier to like manipulate and stuff. So that's why we do that. And head, the reason why we do head is it just shows the first 5 values of the data frame. And if I want to show the like last 5 values, I can do like tail, and it shows the last 5. So yeah, this data set's not that big. So it's around like 550 objects, or yeah, or rows. And if you want to show like the shape of it. df.shape, and it shows you 550 rows by 7 columns. So that's how you read in the data. And you see, that's why we have to import it as PD, because like it makes it easier because it's abbreviated and we can just use this function. So read CSV is a function, and what we put inside.
I had a question real quick. When you open the file, it says cannot edit in read-only editor. So how do you like add the code with the text?
Oh, in this thing, or in this thing? Oh,
yeah.
That's kind of weird. Do you want to like make a new one for yourself, or like just start a new one? Just call it like whatever, and then like just follow along. But like just make a new one and then do like the same thing like I did. You know.
Okay, thank you.
That's kind of weird though. But I was just trying to like structure. I don't know. I'll have to check that out later because I have no idea. I'll like test it out next time before I send it to you guys. But yeah, okay. So to keep going, this is like a function we use, and then this basically allows us to read the CSV file. And then now we want to add weighted ratings, and I like you guys might be like, what the hell's weighted ratings? So basically, let's say you have 2 different books, right? And they're both 5 stars, but then one book has like 10,000 ratings and then the other one has 1 rating. Then obviously the one with 10,000 ratings is better than the one with 1 rating, right? Because that 1 rating might be like the author's like mom or something, just giving it a 5. But then the one with 10,000 ratings is like more credible because there's more reviews and stuff. So we want to take into account the number of reviews when we're doing this. And let me just copy this from my like answer thing, but it's a formula that IMDb uses, which is basically like the movie company. But let me just like put it in here. You don't have to like really understand the formula, but you just have to understand like how we're gonna apply this formula to the actual data set. Okay, so we're gonna create a new column basically. So you see how we have all these columns here? We're gonna add a new one called weighted rating. Okay, and I'm gonna teach you guys how to add that. So basically, let's just follow this formula. So it says M equals minimum number of reviews required to be listed in the bestseller list. So we're gonna say M equals the minimum. And then if we wanna find the minimum on this column, this reviews column, right over here, we wanna find the minimum. So we're gonna call the function min. And then basically to get that column, we do this. So you take in the notation is df, and then you take in the use brackets, and then whatever column is, you just put in single quotation marks and then the name of that. So if I wanted to do like name, then it would be that one. If I want to do author, it would be like that. Okay, and it basically just returns the row, and we want the minimum of that because M is the minimum number of reviews in that. And then next, we want to get the mean rating in the entire data set. Oops, let me clear that. So rating is, we're looking at user rating over here, right? So what we're going to do is we're going to do C equals df, and then we're going to say user rating. And then we're going to put mean. Okay. So what that's going to do is it's going to take all these user ratings and then like find the mean of it. So it would be like 4.7 plus 4.6 plus 4.7, whatever, all the way to like the 550th one, and then divided by 550. So it's basically finding the mean over the whole thing. And yeah, so we're gonna do that. And then those are just like certain constants. And then now we want to apply this function over like the entire thing basically. So to do that, we need to create a new function called weighted rating. And then we're gonna take in certain data, and then M equals M. So these are certain like constants that we're taking in. I'll explain this like more after I write it down. But yeah, so let's first do V equals, so number of reviews for a certain book would be data. Number of reviews is over here. Okay, so we're going to take in that. And then the next formula would be average rating. Okay, so R equals data user rating. Okay, and then we're going to return this basically this formula. So B divided by plus M. Yeah, so right now this might be like a bunch of random math numbers on the screen, but I'll explain how we basically converted the symbols into the code. But yeah, so I'm gonna just write it down first. But right now we're basically just copying the this formula. So first, M is equal to the minimum of DF reviews. So DF reviews is this column here, and we're just finding the minimum in that entire thing. So to make this easier, we can just print that out. And then C is equal to, in this formula, this C is equal to the mean rating in the data set. So all these ratings added up and then divided by the total number of ratings. So that's the mean. Or wait, that's pronounced. And then V equals data reviews. So what that means is for all of these reviews, we put it into this like list basically. So let's print that out too. And then print this out. So what this is going to do is we're going to basically take in the reviews and the ratings, and then we're going to apply this entire function onto the whole thing. And then we're going to create a new column with that. And yeah, so what I mean by that is, let me just like run the thing, and then you'll be able to see. Wait, so for now, this is the mean rating of the entire data set. So let me just say the mean rating, which is like pretty high, like 4.62 is like pretty high. But our data set is the like bestsellers, so this is like expected. So here's like explanation for that. And then how we're going to apply this to create a new column, right? Because we want to create a new one called weighted ratings. So to do that, to create a new column, we do something like this. So we define a new column. It's like the same thing as getting a column, but we define a new one. And then we basically want to apply this function to create the new one, right? So what we want to do is we want to apply this function onto our data. So what's our data? Our data is our data frame, right? Our like this whole thing. So we're gonna put that in. Okay. And then we're gonna put axis equals 1. So what axis equals 1 means is it's gonna place it on to the columns basically. Oops, what the heck? It's gonna place it onto like right here if we put axis equals 1. Okay. And to show you guys, we're just gonna run it and then you'll be able to see. Oof, what the heck? Let me do. I think it's running still because it's yeah, it's giving that. So let's just wait for this to run and then it'll show. Oh, what the heck? I just noticed. You probably don't need that because we can just do. Wait. Yeah. What the heck? What the heck? Wait, let me go check my actual code real quick. What the heck? Wait a sec. X. Oh, oops. I just noticed. I lied. So data actually represents like the value. Oh, wait, let me explain this. So data actually represents like the value in each column. So it does it by like the column. So how do I explain this? So so data doesn't actually represent the entire data set. It just represents like the value in each column. So so how the function does it is it takes in one value from the data set first. So it takes in like 17,350 first, and then it takes in 4.7, and then that produces our weighted rating for that row. And then it moves on to the next one. And then it creates another weighted rating for that row. So it just represents like each row basically. And then it just creates a new one for that. So it doesn't represent the whole data set. Dude, I actually messed that up. But yeah. And if you see our df.head, it creates the weighted rating. And if I want to sort that, I can just do df equals df.sort the values. And then what's a value you want to sort it by, we could do it by weighted rating. Ascending. Oops, got that wrong. And then let's print that. So give me a sec. Let me clear my drawings real quick. So ascending equals false just means that the largest is on the top. And then if I do ascending equals true, then the worst one's on the bottom, basically. And you see how the weighted rating like drops by a lot because some of these reviews have like no reviews, or some of these books have like no reviews, which is why like it's just, yeah, it sinks by a lot. But some of these really good ones have like a lot of reviews and it's like a very high user rating and stuff. And that's why it has such a high weighted rating as well. So yeah, wait, this one's like, dude, or wait, let me just like comment this out because it's, yeah. Okay, so here we have our weighted rating now. So we basically applied our function onto that. And then we got this, and then let's start answering some of the questions, right? So who are the top 10 best-selling authors? So how are we gonna do this is basically some of these are the top 10 best-selling authors are gonna have the highest like weighted ratings, right? So what we're gonna have to do is we're gonna have to find the author that basically we have to take the mean of all their books and then take the weighted rating of the mean of all those. And the one that has the highest is basically the best selling author. And to do this, what we're going to use is we're going to use another function called the group by function. And we're going to group it by the author because this author might have hella books. So like Dr. Seuss, he probably has like Cat in the Hat and stuff, or he has so many more books. So we would have to group it by author. So we're going to have like author, what? We're going to have like, what the heck? Okay, never mind. So we're going to have like author 1, and then like author 1 might have like book 1, book 2, book 3, and then we basically have to take a mean of the weighted rating for all of these books, right? So we have to group it by the first author, and then we're going to group it by the second author, and then we're going to keep taking like their books and stuff. And then we're going to take all those weighted ratings, and then we're going to find the highest one. Okay, so our first job is we have to group it by the author. And to do that, we're going to use a function. Let me just create a new data frame called the top 10 authors. So we're going to group it by the author. So the author is this column, right? So we want to basically follow this diagram, which is we want to take the author and find basically all their books and stuff. And do as index equals false. So what as index equals false means, it's like what it does is it creates a new column basically, but that won't make too much sense unless you have like used it before. But what we're going to do is we're going to take weighted rating. Oh wait, let me clear my drawings so you guys can see. But we're going to take the weighted rating and then we're going to find the mean. So weighted rating, we're going to take this, all their books, we're going to find the mean of all those weighted ratings, and then we're going to sort that by finding the highest weighted ratings. Okay, so this is like super long, but if we break it down part by part, then it's going to make more sense. So to get the top 10, we take the head and 10. So I typed it all out first, but then now we're going to try to decipher what the hell we just did. So basically, these are the top 10 authors. So first, we're going to talk about this part right here. So we grouped it by the author name. So any book that has this author name, we're going to basically put it into like this pile. So any book with this author name, we put it into this pile, right? All these books, book 1, book 2. And then after that, we calculate the weighted rating for that. So let's say book 1 was like 4, book 2 was 5. Then now you have your weighted rating of 4.5. So we took the mean of all those books per author. And then that's for author 1. And then now author 2. You have like book 1. Let's say this guy has like 3. And then book 2 is like 5. So then you get like 4. Okay, so we do this for the entire data set. So for every single author, we do like this type of calculation, right? And then next, we sort all those values by the weighted rating. So then author 1 is obviously going to be better than author 2. So it's going to be higher, right? So then for every single one of them, we compare their basically their weighted rating. So maybe we have like author 3 with like 4.7, then author 3 is going to be better than author 1 and author 2. So then, yeah, we just keep comparing it, and then we basically take the top 10. So to take the top 10, we had this function dot head, and then we basically take the top. And yeah, we're going to be left with a data frame that looks like this. And then let's say we want to plot this, right? We want to plot this, and now we're going to use our library called matplotlib. And to do that, let's just do plot.bar. And then what we're going to do is we're going to take in on the x-axis, we're going to do the author name. And then on the y-axis, we're just going to put the weighted ratings. So what we're going to expect is we're going to expect like the top person to be up here, right? And then the people who are worse to like, yeah, basically descend like that because it's like the top 10, right? So to do that, to put the author on the x-axis, what we're going to do is we're going to do df, or wait, this one is going to be top 10 authors. And then our column name is called author. So we're going to put that. And top 10 underscore authors. We're going to put the weighted rating on the y-axis. So in this example, this function basically tells us to put x comma y, basically. It's basically like that. Okay. And then that's going to give us our plot. But once I print it out, you're going to notice like you can't really like decipher the difference. And to explain that, it's because if you look at these weighted ratings, like there's not like a huge difference. You see that that's like a 0.0001 difference. So now we have to basically zoom in to be able to see like that difference. So to zoom in, we do plt dot y limit. So y limit basically sets the bottom and the top limit of our chart. Okay, so we want to be able to like zoom in and stuff. So instead of starting from 0 right here, we're gonna start from like 4.895 or something, and then let's go to like, what's the very top, like 4.9 or something. And then now you're going to be able to see like this staircase type of thing. And then it's like if I add another 9 or something, oh wait, what the heck, that's too high. Let's do like 5. Then you're going to be able to see like a bigger difference. But that's only because like with this one's kind of jank because the difference wasn't like huge. So that's why you have to set like this, yeah. And then you notice over here, like the names are like all messed up. Like you can't even read that. So to fix that, what you want to do is you do plt.xfix, and do rotation equals 90. So what that means is for these names, they're just going to rotate it 90 degrees. So it's going to make it easier to read. Okay. And let's say we want to label this chart, then we would do plt.xlabel. So this is going to label our x-axis. Okay. So set the label for the x-axis. Let's call this author names. And y label. This is going to set our name for the y-axis. And we're going to call this weighted rating. And then let's say we want to give it a title. I'm going to just say, let's just say who are the, yeah, let's just do that. And then now you see we have this title, we have these, the x-axis labeled and the y-axis labeled, and we get to see like, here are the top 10 authors. So number 1 is Sarah Young. Dude, honestly, I don't even know who half these people are. So, but yeah, these are top 10 authors. And then, yeah, so we can do similar steps for basically all of these questions. So the best-selling books, instead of putting author here, we group it by books, and then basically the weighted rating method is like the same. It's just we're just grouping it by books now, and that's it. That's the only difference. So I could basically copy this and then like do the same thing, but like just change it to book. Or in this case, we called it name. Or yeah, the data set called it name. So instead of this, we can just do books. And then it gives you the same thing, but now by the books. So why would I do it books? Because you guys might be like, okay, there's probably only one book. But the thing is, like, this one is like a data set for like a couple years. So you might see like the same name pops up like 3 times because like the date's different. But yeah, so that's why we still have to group it by the name. And now that we have the top 10 books, we can like basically do the same thing as over here. So like we could just take this and then like do the same thing. But instead of this, we would have to put name, and then here we would put books, and then here we would put books, and then yeah, and then I don't think we need that anymore. And then here let's put book names. Who are the top 10 best-selling? And yeah, oh wait, we might need the y limit thing again. But yeah, let's put from like 898 to. But yeah, so now you see it's like a very similar like procedure, right? We just group it by like the name, and then we see which one's the highest by the weighted rating, and we do the same thing. And you can do this for like a lot of different stuff. So here it says top 10 most expensive books. So instead of the rating, we would have to like sort it by the price, right? So for this one, we would have to do it by the price. So let's do top 10 most expensive ones. And then we group by the name of the book, right? And then false. And then we're gonna take every single price of the book, find its mean, and then sort it by the price with the highest one on top, okay? Let's see that. So it was basically the same step as before, but instead of the author name, now we're using the book name, right? And then instead of finding the mean of the weighted rating, we found the mean of the price. And then we find the highest price. So yeah. And we see here the highest price is that. Oh, and then we'd have to put head 10 because we only want the top 10, right? So here we see the prices, and then we can do the same thing. We can just like plot it again. Let's just like copy that. Then here do exp, but we're not looking at weighted rating. We're looking at price, and then top 10. And yeah, wait, what the, get this up. And yeah, now you can see the top 10 most expensive selling books. The most expensive is, I don't know, Diagnostic and Statistical Manual of Mental Disorders. And then Twilight, and then, yeah. And official SAT study guide. That's funny. But yeah, so that's how you find the top 10 most expensive ones. So you guys can kind of see it, like the method is kind of similar already. After you kind of see how we did it over here, you kind of see like we're basically doing like the same thing. Now for this one, I think is different. So what are the portions of nonfiction versus fiction books? So our job here is finding the percentage of nonfiction and percentage of fiction, and then like creating a pie chart with that. So like we'd expect a chart that's gonna look like something like here, like this, 50% fiction, 50% nonfiction, something like this, right? We want to make a pie chart, basically, is what I'm saying. Okay, and to do that, we're gonna first do, we're gonna say portion equals df, the genre, values, and then we're gonna take value underscore 10. So let me print this out to show you guys what this means. What this means is it's basically found, yeah, where's genre? So for each one, it's labeled by a certain genre, right? It's like labeled nonfiction, fiction, nonfiction. And then what this basically did was it counted the number of nonfictions and the number of fictions. And then now we have that here, basically. So we know the number. So all we have to do is we have to take the sum of that and then basically find the percentage. And that's basically it. So we would do portions divided by equals the sum of portions, right? Because the sum would be this added by that, and then we just divide by it. So that gives us a flat percentage that we can use, right? It gives us that percentage that we can use. And then we can create a pie chart with that. So our two categories, so for this one, it's a little different. So it's not like by X and Y. It's more by the labels of it. So we would have to call something called label. So the first one is called nonfiction. So we can like just put that there. And the second one is called fiction. So that's going to give us distinct categories that the pie chart is going to be able to show. And there's this thing called auto percent. So it's going to show the percentage basically. And to do that, we do that. So that's like two, basically gives us 2 decimals. You guys don't have to know that much about it. Yeah. So now you see this graph or this pie chart, and it basically shows us the distribution, and it shows that there's more nonfiction than fiction, basically. And yeah. For the next one, okay, wait, these ones are a little hard, so I might show this like later on. But for now, I feel like this was I want to give a quick summary of what we went through, because I know like it's a lot. Like we just jumped from like for loops to like a bunch of like data stuff. So first, what we did, let me annotate. So first, what we did is we first imported these libraries. So pandas is for basically reading in the data. So this is reading data plus like sorting it. So we sorted it by the highest price, the highest rating, and all these different other metrics and stuff. And yeah, and then the next one is matplotlib. And what this does is this allows us to plot stuff. So all this plotting over here, this image, this image, this image, and this image was all done under matplotlib. So this is going to allow us to plot stuff. And what we did is we plotted a bar chart and we plotted a pie chart with it. Okay. And first, what we did is we have our CSV in our like main file over here, right? And then what we did was we basically scraped it in. We read it with the with our library. We read it in, and then we printed the top 5. So this is the top 5. And then we read it in through this function. Okay. And then after that, we wanted to create this thing called weighted ratings because we wanted to make sure that the ones that have more reviews would have a higher rating. And we want to take that into account because we want to make sure that the ones that have very small ratings wouldn't be like instantly found as like the best, because if it's so small, then maybe it's like rigged and stuff. So to do that, we have our like little formula over here, and then we have to basically apply that to create a new column. And to do that, we first had to let me clear that. We first have to find M, which is the minimum number of reviews. And to do that, what we did was we basically took our DF reviews, and this represents the row. So this represents that. And then we basically found the minimum of the number of reviews. And we found that, we found that it was 37. So yeah. And then after that, we found the mean, or in this formula, we want the mean rating in the data set. And then we basically took the column, which is user rating, and then we took the mean of that. I mean, I think that was like kind of self-explanatory. You just have to know like these functions exist that allow you to do that. So yeah. And then after that, we created a function, and why we need this function is we want to be able to apply this per each column in the data set. So for every single row, we want to be able to take in a certain user rating and a certain review, and then translate that to a certain weighted rating. And that's why we had to create this function that I kind of messed up, but it's all good. Yeah, make sure data doesn't represent the data set. I don't know, I'm kind of slow, but yeah. So make sure it just represents like every single per each value in the row, and then it calculates for each value in the row what the weighted rating is, and then it goes like that. So this arrow represents basically the function, and what we did is we basically defined the the values per row. So this is per row. And then we basically applied the function. It returned this formula, which is basically this formula. And then, yeah, we just applied it to the data set, and then through this thing. We applied it through this, and then that creates a new column in our data set, basically. Okay. And then after that, what we did is we sorted it. So for the weighted rating, we want the highest on the top. So that's why we made sure ascending equals false to get the highest on the top. If we didn't want to do that, we could put it as true. So then the bottom, the worst ratings are on the top. And yeah, we called a function called sort values. Okay. We sorted it by the weighted rating. So this is the column name we want it to be sorted by. And yeah, and then next, we want to know who the top 10 best-selling authors are. And this is like when stuff gets kind of hard. So what we did is we first grouped it by the author name, because we want to make sure that we want to get the author, and that's why, basically. So that's why you want to make sure to group it by the author first, because what the group by does is, let's say one author has multiple books, then you're going to be able to group it by that. And then this is going to take the mean rating of all of that. And yeah, so we're going to be able to take the mean rating of all these books and stuff. So that's why we want to make sure to group it by that first. And then for each author, you're going to have a certain mean, right? So boom, this guy's going to have another mean. Another author is going to have a mean. So now you're going to have a list of a bunch of means. And then maybe this one's, and we basically want to sort it to make sure like the best ones are on the top. And that's why we sort the values again over here. And then the top 10 are there. And then, yeah, so that's enough in terms of sorting it. And then after we sort it, we want to make sure we can plot it out. So the we plotted out by first putting like on the x-axis the author names over here, and then the weighted ratings on the y-axis. And yeah, and then we labeled it using these functions, and yeah, and we also constricted it within this limit. And then we basically did the same thing for the rest of the stuff. Here we did it by grouping it by the name of the book, right? And then we did a rated rating again by the name of the book, and then sorted it, and we found the top 10, and then we did the same thing basically. And then this one basically did the same thing. We did it by the name of the book, but this time we did it by the price. And yeah, we found the top 10 most expensive books by the price. And then here we have it. We found the pie chart basically. And to reiterate, what it does is portions basically gives us the number of nonfiction and then the number of fiction books. So it gives us like a certain value. So I'm not too sure what it said before. I think it was like 310 by 240 or something. So now we have this, but we want to convert this to percentage points, right? Because plot charts use percentage points. So to do that, we have to divide this by the sum of it. So 310 has to be divided by 240 plus 310, and then 240 divided by 310 plus 240. And that's what this line does. And then after getting the percentage, we basically put in our portions little thing that gives the percentages and stuff into this function called pi. And then magically, this thing just appears. Not magically, but like the library basically like takes in your data and it just outputs that. And yeah, this stuff I think is a little too hard for now because this stuff like requires, yeah, it's a little harder than what we're doing right now. And I might post it later on to explain, but it's like kind of like optional information. Okay. And yeah, I think that's basically it. I think I might make like a classroom assignment so that you guys can like input like your responses and stuff. But yeah, is there any like questions about this entire thing?
Yeah. When you said ascending false, right? Could you
Yeah.
put descending true or something like that? Like instead of ascending false, but descending.
I'm not sure because they have like heck of functions. They have so many functions, and I don't really keep track of them. But I mean, we could try. But yeah, I don't think you can. I guess.
Okay.
I mean, it's the same thing because like descending true is yeah.
Okay.
But yeah, dude, if you really like read into like their documentations and stuff, so this is the IMDb stuff, this is the group. So they have like so many functions, and it's like actually kind of hard to keep track of. So like, yeah, they have like so many functions, and yeah, so by just means which column we're dealing with, and in that case it was like the weighted rating, not that one, it was the weighted rating, and then yeah, so they don't have descending equals true. Is there any other questions? Low key, like that was like a big jump, so maybe I might for the next one like tone it back a little because yeah.
In the group by function, what does the as index do?
Okay, so what the as index does is it basically creates a new column with it. So we can basically test it without it. Because if you don't have this as index, you're not going to be able to find the column of the author without it. So what I mean by that, we can basically just like try it without. So let's do like 2. Let's just do the same thing and just like not include it. You're gonna see like we're not gonna be able to access it basically. Like you're not gonna be able to access the author. Like yeah, you're not gonna be able to access it.
All right.
This you have a group by function, and then yeah, you're gonna have to do as index to be able to even like use it. Let me do. You're gonna see. Wait, let me take this out. So you're gonna see like authors on the side over here, but then like you're not gonna be able to use it. Like I can't just say like let's do this. And then let's say I want to access this column. You're not going to be able to access it. It's going to say like, it's not going to be able to find it. So that's why we have to say as index equals false. And then you see how it makes another column for that. And yeah, it's just one of those finicky things that like you just have to kind of know exists. And yeah, that's why.
All right, thanks.
No problem. Is there any other questions? Okay, I think that's basically it. I think I might try to like annotate this thing more. I'll post it on the resources thing, and then yeah, I'll try to create explanations for the bottom ones because these ones are like harder. And yeah, I hope you guys like learned something from this because I know it's like a lot to take in, but like we're finally getting into like actually like working with data and stuff, and we're not just doing like random algorithms and stuff. Like we're actually doing stuff now. And yeah, hopefully it was like fulfilling to see that. And yeah, I think that's basically